Okay, let's look at points a little bit in more detail here. So let's go into, let me throw all these things away. Let's go into basket 1 here. And let's look at the points. So the first thing you notice is that iDig will store its points as these polygons or just a series of points. There can be multiple ones. Here there's one for the open. Here there's one for the close. If I go into one of these, you'll notice that these points are green because they came in from the total station. If I just start adding new points here, these touch points are going to be orange because they're marked as touch points. The touch points, I can double tap them to delete them. They're meant to be temporary points. I can hold down on them to move them around. Okay. The total station points, if I try to hold down on that, it's not going to let me move them. Okay, they're a little bit more difficult to edit because you don't want to unnecessarily or by accident change your total station points. You can edit these manually. You can go into any one of these point lines. You can rearrange the points so it swaps them. You can go in and edit these points. So right now this is 405 meters over. If I change it to 403 meters over, it's going to move that point to a new location. So even though it's a total station point, it will let me go through and manually edit if I want to. I can move that around.
It will be still green or no?
It will be what?
Green or no?
Wind?
Green.
Green? Yeah, it'll still be green because it came from the total station. So that's just marking the total station point versus the touch point is the color, is what it's doing there. You can see, if I get rid of these touch points, let's put one back to where it was.
If we double tap the green points, can they be erased as well?
No.
Okay.
No. The total station points are a little bit more difficult to change on purpose. Yeah, that way you don't do that accidentally. You'll notice on these total station points as well, they come in with elevations. They have the 3 points. And also, if you tap on one of the points on the right, it's going to try to highlight it on the left and vice versa. If I tap on one of the ones on the left, it's going to highlight the one on the right. There are some things in parentheses here. If I select one of these points, the HR measurement is the height of the rod. So that comes from the total station, and the reason we put that in there is because a lot of times people get the height, they won't enter the height of the rod correctly in the total station when they take their points. So that's just a double check to make sure that when people are taking points, the height of the rod is what they expect it to be. The distance measurement, DST there, if you select one point, the distance will be 0, and then all the other distance measurements will be the distance to that point. So if I tap point 4 distance is 0, and if I look at point 1 here, it's 1.923 meters away from point 4. Point 2 is 1.131 meters away from point 4, and so on. So as I touch these points, those distance measurements will change. And that's just for a convenience where people are doing their baskets and they want to know, like, what's the distance between point 1, say, and point 11. I can tap on point 1, go to point 11, and then I can see that the distance here is 2.72 meters. So it's just a way of easily grabbing the distance between the various points that you're looking at. Okay?
You said something before about the rod's elevation. I missed it.
That's the HR number in the parentheses there.
Okay.
So if it's a total station point, you'll see an HR number. If I make a touch point here, it's not going to have an HR number. It's just going to say the distance. And it also, the other thing that will happen is if you have total station points and you start doing touch points, you'll notice that it's actually adding the elevation in there for me. So what it does, the Swiss used this for a number of years where they were doing all their points manually, And so once you enter one elevation for one point, and then you start making touch points, it's going to try to use that elevation throughout to make it easier on people who are entering them manually. Or if you have multiple points, it'll try to average to get you an elevation there.
Just in case it accidentally moves a little bit.
Yeah.
Okay.
Can you change the height of the road based on?
Height of the rod? No, that comes directly from the total station. I can't edit that data, just the X, Y, and Z coordinates.
Any additional data elements coming from the total station that aren't visible here?
There are a bunch. There are a bunch that will be in the database. Yeah, when you open up the raw export, you can see all the different fields that the total station spit out when it took that point. Okay, so that's points. So let's say someone emails you a new plan. So if I go to my email, I hold down on the plan that someone sent me, and I say I want to share that with iDig. It's going to automatically pull in that image, that plan image, but it's going to bring it as a photo because it doesn't know if it's a plan or a photo. It's not that smart. So what I can do is, let's say I'm going to take this photo that came in, and I'm going to change it to a plan type. I'm going to force it to be a plan. I'm going to say this is a plan. Okay? So now iDig will be able to draw the plan on the right. Okay? And I can start looking, I can start making points on this plan. So let's add a point. Let's go over here to the corner. And you can see on the plan, it's got a 430 marker here and then a 435 marker. And it's got a 360 marker on the north side here, 355, 360, so on and so forth. So this point where they cross right here, okay, so this point should be coming in at 360 meters up and 435 meters across. Okay, but the actual value that you're getting for that point is something kind of different. 964 over, 152 up. Okay? So what are these numbers? So if it's supposed to be 435, 360, it's not. What happens if we go over to the 430 line here? Let's move it. So it's 964 over now. I move it over to here. It goes 711 over. I keep moving this around. 462, so it keeps going down. So like if I say like, okay, where's 0, 0 on this plan? So I'm gonna change the point to 0, 0, 0. Okay?
Which? Oh, okay.
And now what you'll notice is iDig thinks 0, 0 is right there in the top left corner. Okay, so if I go down, let's say I change the y value to like, let's say 200 or something. Now it's gonna move it down that way. If I change the x value to like 200, that moved it over. Okay, so iDig thinks that the 0, 0 coordinate on this plan is up here in the top left corner. Okay? So if I take this, sorry?
Shouldn't it be the observatory?
The
observatory.
the observatory. Yeah, on the Agrog grid, the observatory up there on the hill is the 0, 0 point. That's right. But on iDig thinks it's in the top left corner of this image. So if I come over to let's go over here to the top right. So let's put this back at 0, 0. So let's say 0, 0, 0. Okay, so it's got one point up there in the top left. If we go over here to the top right and try to move this point up here to the top right as close as we can get it. 2006 over, we can put this at 0 too, so it stays in the same way. So this is 2006 over, so let's make it go over a little bit more. Like how about like 2017 or something like that? Okay. So now we're way over on that side with 2017 over 0, 0, and then let's look at the bottom here. Put one down here at the bottom. So put this way down here. Let's try this again. Down, go back. Okay. Now you can see the full numbers. So, so we can change this x value to make it the same as the top. 2017 by 1386 or something. So it's almost at the bottom there. Maybe we can increase this a little bit more and make this like 1400. Okay, it's almost at the bottom at 1400. A little bit off.
Assuming those are pixel or raster values.
Okay, now we're getting somewhere. So what are these values? As Michael just said, maybe they're pixel or raster values. If we look, so right now, basically, iDig thinks this plan goes from 0, 0 in the upper left-hand corner to about 2017 by 14 something in the bottom right-hand corner. So what are these values? If we look at the plan, if you look at any one of these images in Photoshop or some image program, you're going to find information on it, and it's going to tell you this plan is basically 2017 pixels across and 1412 pixels up and down. So what we're actually looking at in iDig is we're looking at the pixel coordinates for the image. Okay? So the image itself, so this is going to be, what are the numbers? 2017. This is 2017 across. And this is going to be 1412. 1412 up and down. Okay? So this is going to define the coordinate system for the image. What the image is going to do internally is it's just going to record pixel values. So it's going to be like 100 over and 100 down. This pixel is going to be blue. And 500 over and 700 down, this pixel is going to be green. This is what the image records. And when it shows you the image on the screen, it simply puts all those pixels, it just puts the image on the screen and it makes all those pixels turn those colors, and what you see is the image. So you're going from what's called an image coordinate system with pixels. And what we want to do is we want to have some kind of coordinate system based on meters. Okay? So we want, for example, the 0, 0 point. What we'd like is for this 0, 0 point to actually be in meters. Okay, so there's 400 meters over, so 399, 398, 397, 396. So we want this to be 396 meters over is where that dot starts. Okay, and then on terms of the vertical, it goes 355, 360. So this is 1, 2, 3 meters, so 363 meters high. Okay, so I'm telling iDig, I'm saying this point here, the 0, 0 point, what you think is 0, 0, I actually want this point to be I want to georeference the 0, 0 point. I want it to be 396 meters over, 363 meters up. Okay? So I do it for at least 3 control points. So I go to the other one. So let's say, now that I know that the distance, let's say the pixel dimensions of the image, I know that the pixel dimensions are going to be 2017 by 1412. So I can set this 2017 over. I want this to be, it's going to be the same height, but the x coordinate is going to be 425, 430, 435, 436. So 436 over. And this is going to be the same height, so 363. Okay. And so iDig is telling me now I have a georeference point. I've added onto the end of the point coordinates what I would like them to actually be. So this one, 2017, is 1412. That should be the exact location of the bottom right. And I want this distance to be 436 meters over. And then how high? This is going to be 340, 339, 8, 7, 6, 5. 335. So 436 over, 335 up. Okay? Once I have 3 control points set up, and I say the equivalent in pixel to meters, so I'm mapping from pixels to meters, then you get a georeference plan button which will appear. And I'll hit this button and it will go through georeference the plan. And now if I come over here to this 435 over 360 up and add another point, now I'm starting to get the actual meter coordinates of that thing. So what's going on here? So there's math underneath this, but you don't need to understand the math as much as it's helpful to understand the concept of what's going on. Let me grab this. Okay. So with an affine, what's called a simple affine transformation function to map one point, you'll take your input point, say pixels, you'll do some math with these 6 magic numbers. Okay, it's matrix multiplication. You can go look it up if you want to, but you don't need to understand it. You just need like 6 numbers, multiply that by your input point, and you're going to get a point in the new coordinate system. The really nice thing about these affine transformation functions is that you can reverse it. You can take those same 6 numbers, okay, and you can rearrange them in a different order, and then you can multiply your point in meters, say, to go back to pixels. So it can go both ways. So in other words, if the total station takes a point in meters, which is what it's doing out there, and it sends it into iDig, and it says this point is 400 meters over and 300 meters up. What iDig will do is it'll send it through that transformation function to figure out where that point is in pixels so that it can just draw it right on top of the image. And vice versa, when I touch the image, it knows what pixel I'm touching. It runs the transformation function backwards to figure out what the meters are for that point. So at every point in time, iDig is going back and forth between the image pixels and whatever coordinate system you have mapped here to use. So let's look at another example. Oftentimes what will happen is you'll get an image back from someone, like the drone photographs they take. Okay, and what they'll do is they'll send you a raw image of some kind, like here, the TIFF file, okay? And we can open this up, and each one of these images is going to have where's my preview app? each one of these images is going to have its own kind of internal pixel space. This one happens to be 1751 by 2040. And what they'll often do is they'll give you this world file that goes with it. Okay? So they'll be like, this world file goes with that particular image. So what is inside the world file? If we look inside of it, it's just a text file. And we look inside of it, and what do we have?
The magic numbers.
The magic numbers. There's N1, there's N2, there's N3, N4, N5, N6. So world file is just a text file with those 6 magic numbers that you need to go back and forth between the coordinate space of the image pixels and whatever coordinate space that world file's for. So you can imagine if I'm mapping this particular TIFF image to the Agarog grid, one of the things you can look at is the last 2 numbers are kind of like the offset, the top left corner. So this is like 398 meters by 363 meters. If you look at, let's say, they give you the exact same TIFF image, but they say, oh, you want to map this to WGS84, they'll give you a different world file that'll have different numbers in it. And this is mapping it to longitude and latitude coordinates. And so the top left corner is 23 degrees by 37 degrees. So just by changing those 6 numbers, you can move that point around in a destination coordinate system. Okay? The only thing you need are the 6 numbers. Thing we're going to do tomorrow is we're going to start looking at the preferences file that defines the types and the fields. So on your dock is this application called PowerJSON. And this application lets you edit these JSON files. So I can take, the main file we'll look at is the preferences.json file. Okay? And if you open this file up inside the JSON editor, at the top right, there's text view. And this will show you what the raw file looks like. It's just a text file. All JSON files are text files with a bunch of stuff inside them. Okay? Or you can change to JSON view, which is what the computer sees it as in these different kind of things. So I'm going to explain to you a little bit about how JSON works. It's a very useful file format. What's going on is that people have spent ages trying to come up with a file format for transferring information between 2 computers that is easy for a computer to read and work with, while simultaneously easy for a human to open up and read. And there's a lot of different competing formats. JSON has come out kind of on top in terms of this interchange format. And it's a lot simpler than it actually looks. So let me walk you through how the basics of JSON here. So let's do this, and let's go down to here. Just start here. Okay, there's basically 5 things you have to know about JSON. Think of it like Legos, and you're building something out of Legos. Okay? There's what's called a string in JSON, and this is anything between quotes, double quotation marks. So that's a string. You can have your name, that's a string. You can have, numbers, you can have letters, anything you want. JSON will just look at those 2 quotation marks and treat everything inside as one little Lego block. That's a string. That's all JSON cares about. There's another type called a number, and this is a number like 1, 2, could be 3.14 or something like that. It could be any number, decimals, negative, whatever you want. That's another type of, say, Lego. The third type that we'll deal with is called a Boolean type, and this either is true or false. Those are the only 2 possibilities. Okay? So those are the basic atoms that JSON works with. String, number, Boolean, say. There's some more, but these are the ones that we deal with. Now, there's two ways of kind of putting these simple Legos together. The first way is called a list. And what this uses is it uses square brackets. And then you can put anything in the list you want. So I can put a string, and then I separate the values with commas. I can put a number, let's say 51.5, and I can put like a Boolean, true. Okay, and it has an open and a closed square bracket. That's a list. So inside a list, you can put any of those kind of atoms you want. Okay? The last thing you have to know to understand this file is what's called an object. And an object is a little bit kind of weird for most people. It starts with curly braces. And then it has what's called a key. It's usually always a string, so some kind of key, string, and a colon, and then some kind of value. Okay, so let's just do something realistic here. Let's do like name is Bruce. Okay, age is 51, and then we can make male is true. Okay, so for an object, what you want to do for an object is you want to think of it as kind of like a bag. And in this bag, I can throw a bunch of stuff. And I'm gonna reference that stuff by its key. So I'm going to throw like name is Bruce into the bag. And then at any point in time in the future, I can say, what's the name? And it will send me back Bruce. I can say, what's the age? It'll send me back 51. So it's like a bag where you can put anything you want inside of it. And usually the keys are strings, and usually the values can be any kind of object you want. In this case, we have a name string, we have a name key, we have an age key, and we have a male key. And then the end of the object is with the braces again. Okay, so this is all you need to know to understand JSON. Now, there's one funky thing here you can do, is that any of these things are basically JSON atoms, including the list and including the object, which means I can do things like this. Let's say I want to make a new key here. I separate my keys with my key values with commas, and I want to make a new key, which we can call it a list. Okay? And what I can do is I can take this whole list here, and I can make that the value for that key. Okay? That's where it gets a little bit funky. I can take a list and use the whole list as a single value for one key. Or what you can do is, this whole thing right here is an object. I can take the whole object, if I want to, and I can stick it inside this list. And that's valid JSON as well. So by using the lists and using the objects, you can define kind of anything you want. So let's just do a quick overview of the preference file. If you look at the very top of it, it starts with a curly brace. Okay? So the entire preferences file is just one single object. And if I change over to the JSON view to see what this looks like, I can collapse all these things down. And there's the whole preference file. It's one object, and it has a comment key with an array or a list. They'll use array sometimes, talk about lists. It has a comment key, okay? And it has an array as its value. It has this version key, a number. It has a project key, which is a string, a max digits key, a string, and then it has WGS84 control points, array, fields, array, types, array. So that's the whole thing. So you can open these up. So if I look at the text view, for example, you can see we start off the object here, And the first key is called comment, and then it has a list. And this list is just a list of strings. So this is just comments for the person reading it with kind of instructions on what's going on in the field. And then you come down further and you can see here we have another key version, and that's values 2, comment. Next key project, its values agra. Next key max digits, its value is 4.3. And then we have this WGS84 control points key, and that's going to start a list. And the list is going to be a list of objects. And in each object, it has a lat coordinate, a lon coordinate, and an x coordinate, and a y coordinate. So these should look familiar. These are basically control points saying, in the agrog grid, 200 over minus 200 is equivalent to that lat and longitude. So this whole object is one control point. Okay? And then as you go down, you'll see there's a whole series of control points here that have been entered that tell iDig where the agrog grid is in terms of WGS84 coordinates. And that's just a convenience so that when you export the data, if it has this field, this WGS84 control points, it'll automatically create all your points both in your local grid and in WGS84 so you can import them into another program easily. So what I'd like for you to do tonight is I'd like for you to go online and look at find a short JSON description that feels comfortable for you. You can look on Wikipedia, but it's a little bit verbose and things. At its essence, it's just those 5 kind of things: strings, numbers, booleans, and then lists or arrays, they'll call them, or objects. And with those kind of Legos, you can build up this whole preference file. So I'd like you to have a little bit of a Google around about JSON so that you feel comfortable with that. And then I'd like you to try to just read through the text version of this. If you open up the preference file in JSON, so you want to go to your dock, open up the JSON app, which is on your dock. And if you open up the JSON app, you'll get on the left, it'll say, I want to look on my iPad. I want to look in the iDig folder. And I want to look at the preferences.json file. Okay? And in this app, there's 2 views of this file. The text view, top right, will be the raw text file, which is what it is on the disk. If you pull that file off and look at it in Word or some other text browser, it'll look like this. If you hit the JSON view, that will show you what the computer understands it at in terms of these different objects and lists and things. If you mess up the text view, if I go into the text view, for example, and I edit it, right now there's the start of the list for comment, but what happens if I take that bracket off and break it? Okay, so now the JSON is officially broken, and when I try to change over to the JSON view, it's going to tell me that there's a parse error, which means the computer's like, I don't understand this file, it's not proper JSON. Okay, so it is possible to edit this file and change the JSON, and if the JSON is not correct, the computer is not going to be able to parse it correctly. If I put that bracket back in there, now when I change back, it's fine. So I can change back and forth. The computer can read it and parse it, it's happy. The human can read it and understand it. So have a look at this file. We're going to go into this in depth tomorrow and talk about all the internal iDig types and fields and things like that. But if you have just a quick read through to try to understand it now, that'll help you tomorrow. Questions?
So we find from Google small code, what I say, and do we type, can we type it anywhere? Here.
Jason, you can type it inside this edit. You can edit the text here.
Yeah, okay.
You can edit the text raw and make it whatever you want. And the computer will try to parse it when you go over. Or you can make new documents. I don't know. I mean, I've looked around on the web and I haven't found introduction. They all seem to explain it in very complicated ways, but you can look at one of these things and see what it does. But I find a lot of times these things end up confusing you more. This is the official way the computer looks at it, but that's not going to really help you very much. But maybe some of these kind of examples that you can find where they show you bits of JSON code and explain what's going on. That might help you get your head wrapped around this idea that you've got those 5 basic items and you can mix and match them however you want. But read through the preferences file as best you can, skim it, have a look, and try to see if you can figure out what's going on. And then tomorrow we'll go in depth on that.
Can I ask something else?
Yeah.
So this is like the back, I don't know, back from the JSON they are, it's defined the code. So you make things from there and then you can open the
So when I open up the JSON app, and I'm looking at all the documents. These are all the documents on my iPad. I'm going directly into the iDig folder. Oops, sorry. I'm going directly into the iDig folder. I'm going on my iPad and I'm going into the iDig folder and I'm editing the preferences for iDig directly. So you could take that JSON file and copy it to your computer and edit there and put it back. But this JSON app on the iPad lets me edit this directly right here. So for example, one of the things I can do, let's do an example here. Let's go down to the text. Okay. Let's go find the first type here. Here are my types. The first type is labeled as a context, and it has these labels. In Greek, if your iPad's in Greek, you'll see the word omada. If your iPad's in English, you'll see the word basket. Okay, so I'm going to change, let's say, this basket word here, and I'm going to say, Bruce. And I'm going to change this, I'm going to say, Bruce's. Okay. So it parses fine. So if I go back to iDig, if I switch over to one of these other agra things now, you'll see that I've actually just changed the type in iDig to Bruce's here for the baskets. And if I look at the menu up there, I've changed the type to Bruce's. So by editing that preference file, you can edit everything inside of iDig and make whatever you want appear.
So JSON is another app to support iDig.
JSON is like what the configuration is stored in. So it can be read both by iDig and by a human, and a human can go through and edit it and make it however they want, and then iDig will read that and use it to configure what you see. The data itself is stored in the trench files. The configuration for that data is stored in the JSON files.
Okay.
So that's how you essentially customize it for other.
That's how you customize it for other excavations. Other excavations will have different type lists. And if you go to Keros, they'll have their own types, their own fields. If you go to Poros, it'll have its own types, its own fields, and so on and so forth. So you customize it by editing the JSON file, and that'll define what you see on the screen.
But you have to change the whole code, the whole thing. If you want to go to another excavation and you don't want baskets to be called baskets, you want them to be called Bruce, let's say.
Yeah.
Or anything, you have to change everything.
Yeah, usually what I'll do is you'll have like the template and you go to an excavation, like what do you call these? Oh, we call them that. Okay, so you just edit that. So you can copy and paste these big JSON blobs back and forth in a text editor to set it up however you want. You don't have to retype it all by hand.
Okay.
Yeah, usually a lot of copying and pasting and just editing and tweaking it.
So if, so for example, I change something here, like we changed it before, then I simply exit this one and
Yeah.
go to my iDig.
You go to your iDig. iDig will load the main preferences at startup. So usually you can quit the app and start it back up again, and that's when it will load the preferences. Sometimes if it's a trench specific one, like on Poros here, so Poros we have dives, artifacts, and so on and so forth. So if I go into the JSON app, I go to my iDig documents, I look for the Poros configuration file right here, go into here, let's change dives to underwater. Okay, Now I've edited the JSON one for Poros. It'll load this when it starts up. So if I go to Poros now, you'll notice I've changed the type name to underwater.
Okay, great.
So you just switch out of the trench, and when the trench loads, that's when it looks for a preference file. And if you've edited it, then it will show up there.
Now are you going to go back and change it after because you, I mean, are you going to switch it back to its original name?
Yeah, I probably should, shouldn't I?
Okay. Because you're a mess now.
If we want to add more preferences, should we like place them in a specific way before or underneath something, like a new whole category, not a one that already exists, like
You can add more wherever you want. Yeah, you can add them wherever you want. Jason will just read it as a file. But like I said, we'll go over in detail that file tomorrow and look at all the iDig types, look at how the file maps these things and sets up the fields. So I don't expect you to know that now. It would just help if you just kind of like look at it in a confused way and kind of got a little bit comfortable with it. So tomorrow when we go through with it, you're not lost.
Okay.
Okay?
it is a programming language, Jason.
Not really, but it's kind of in between. The programming part comes when you realize I can have an object that has keys and values, and instead of a value, I'm going to stick in another object. Now you're starting to think like programmers think. It's like, and inside that object, I can stick a list and stick another object, and it just kind of goes down, down, down. That's kind of programming mentality, but it's not really a programming language. It's more of a description of all this data and how it relates to each other.
And each JSON file is individual, so if I change something in my preferences, doesn't mean that everyone else.
No, it's your iPad, your data.
Okay.
No one else can have that. No one else will have that until you give them to them
Okay.
specifically. And remember, the way it works is there's one default preferences file is what it uses for everything. But you can also rename it to a trench-specific name, and then it will use that preference file for that trench.
Okay.
So that way you can have multiple excavations on one iPad, each with its own preference file defining the types, fields, and things like that.
Great.
Okay?
Okay.
All right. So I will see you tomorrow, and then we will dig into the preferences.